Is all about finding the gradient of a curved line given a graph. Let's read the first question. The graph shows the temperature of a fish tank over the first 6 hours after a heater is added. By drawing a suitable tangent, find the estimate of the gradient of the curve when h is 3. So find an estimate for the gradient of the curve when h is 3. So when h is 3, I want to find a gradient at this point here. Now, there's a fact you have to know about curved lines. It's that curved lines have differing gradients depending on the points. For example, at this point here, the gradient's like a medium positive. At this point here, it's like a high positive. At this point here is like a low positive. At this point here is a high positive. At this point here, there's no gradient, it's 0. At this point here, it's a high negative. So when it's going uphill, it's a positive gradient. When it's going downhill, it's a negative gradient. If it's flat, it's got a 0 gradient. So I have to find the gradient at this point here. And this question is quite nice. It tells you what to do. In order to find the gradient of a curved line, and you're given a graph, you have to draw a tangent. A tangent is a line that touches this point only once. So it won't intersect the line like this. It'll touch and skim like this. Ooh, that's not good. Something like this, where it skims this point. Now we have a tangent. We can use a straight line, and in order to find the gradient of a straight line, we can use rise over run. So we're going to choose any two nice points along this blue line. I'll choose this point here. It's been given to me. And then I will choose, I don't know. This point here looks pretty nice. So I'll draw a little triangle. So let's do the rise over run. Well, the run's pretty easy. It's going from 1 to 3. So the run is 2. The rise, well, let's find out. So I think it's going up in 0.5. 0.5, 1, 1.5, 2, 2.5, 3, 3.5. So this is about 3.5. And this point here is 12.5, 13, 13.5. So from 3.5 to 13.5, the rise is 10. So rise over run is equal to 10 divided by 2, which is 5. And since this point is going uphill, it's going to be positive 5. So our gradient is 5. All right. So you can do this one by yourself. Next, the graph shows parts of a graph of y equals fx and y equals gx. So fx is this line here, and gx is this line here. Calculate the value of x, where the gradient of the curve y equals gx is 0. So we're going to focus on this part here. We're trying to find a coordinate where the gradient is 0. Well, the gradient is 0 is at this point here, the turning point. So if I draw a tangent, it'll be flat. So I got to find the x coordinate of this point. So it's about 3. X equals 3. Calculate an estimate for the gradient of the curve of y equals fx at the point on the curve where x equals 4. So we're going to focus on this curve here. And we're going to find a gradient when x is 4. So when x is 4 is here. So we're going to find a gradient at this point here. Let's draw a tangent. That looks pretty good. Let's choose two nice points. Let's choose this point here. And let's extend the line as long as we can. Gosh, I don't even know. Let's do this point here. So we'll draw a little triangle. Well, the run's pretty easy. It's going from 4 to 6. So this has a length of 2. The rise, well, I think it's going to be in 0.4s. Minus 2.4, minus 2.8, minus 3.2, minus 3.6. And this point here is 4, 4.4, 4.8. Let's just say it's 5. It's just an estimate. So the rise is from minus 3.6 to 5, which is a jump of 8.6. So the rise is 8.6. The run is 2. Rise over run is 4.3. And that's going to be our gradient at that point. You can do these two by yourself. Last section. By drawing a suitable tangent, find an estimate of the gradient of the curve when x equals 1. So x equals 1 is here. So this point here. I have to find the gradient. So it's a curved line. And it tells me I have to draw a tangent. They're very nice in this question. Sometimes they don't tell you to draw a tangent. You just have to know that. That looks pretty good to me. So I'll choose this point here. Let's choose, I don't know. This point here looks pretty good. Let's draw our rise triangle. Our run is pretty easy. It's from 0 to 1, which is 1. Our rise, this is about negative 3.5. We're going to negative 1. The gap's 2.5. So rise over run is 2.5. And that's my gradient. A point D lies on the curve. The x-coordinate of D is negative. The gradient of the tangent at D is 0. Write down the coordinates of D. So D lies on this line. The x-coordinate of D is negative, so we're only going to focus on this section here, so on this part of the graph, because our x-coordinate has to be negative. The gradient of the tangent at D is 0. So I'm trying to find a point along this line where the gradient is 0. Well, it's always the turning point. So if I draw a tangent, it'll be flat. So the gradient of this point is 0. Write down the coordinates. Well, it's going to be -2, 8. So the turning point always has a gradient of 0. Next, write down the range of values of x when the gradient is positive. So gradient is going to be positive, negative, or 0. This point here has a gradient of 0. When it's going uphill, it's positive, like from here to here and here to here. And when it's going downhill, it's negative, like from here to here. So I'm trying to find the range of values of x where the gradient of the curve is positive. So I'm going to focus on the purple sections only. So I'm going to write some inequalities down. So for this section here, x is bigger than 3.5, negative 3.5, but less than or equal to -2. And this section here, x is bigger than, it starts at 1. It starts going up at 1, and it ends at 2. And that would be our answer for that section there. And you can do the rest of the questions by yourself.